All right. So, what astronomical significance do they have? So this is what I want you to know about all cultures that we talk about. Where they were, when they were, what's their astronomical significance, and then each one might have something special about them. But what astronomical significance did the Pawnee have?
Their big old huts. Or
Yeah, Earth lodges, they call them.
Yeah.
And what was astronomical about them?
It was like a gauntlet for morning star, evening star.
Right, it dealt with their story. How many of you read the Haxty story about the sacrifice? Was it kind of harsh? It was just very different than you kind of expect, right, nowadays, okay. Yeah, what else? What was special about them? What direction do they face? East, they always face east. So the cardinal points, that's one of our astronomical alignments. So they're aligned by cardinal points. What else? How many posts were there? Or they could have more than that, but how many main posts? Four, which signify
The directions.
yeah, cardinal points, seasons, beasts, four different colors. It actually signified 4 different stars as well, which were signified by the seasons that they were with. True. All right, and we talked a little bit about their main god and goddess were
Morning star and evening star.
morning star and evening star. What color was associated with morning star?
Red.
Red, and we think astronomically that was probably
Mars.
the planet Mars. Evening star, we don't really have any actual star. We don't know what that was supposed to be, but and what was the story, or how did mankind come to exist in their beliefs? Yeah, so morning star he had to overcome many trials, right? She kept sending all kinds of crazy things at him, and he had to overcome those trials, and eventually he did. They laid together, they had a child. The child was a female child. So the first was a female, and then all descendants of that, the people came from that one child, supposedly. Okay, good.
So evening star and morning star had a baby?
Yes. Yes, and their baby was all of mankind. All right, now we're going to move on to a new astronomical thing. That was all about cardinal points. We talked about the Egyptians and their pyramids. Mostly it was all about their pyramids, okay? When they were built and how they were built and all that kind of stuff. And we talked about them because they were all lined up for cardinal points, right? North, south, east, and west were very important to them. We're going to move on to what we call zenith, solar zenith, or solar noon altitude. All right, so for this part, you got a protractor, right? Get out your protractor. If not, get one. And this is when I told you we're going to start drawing some exact drawings. This is going to be where we're going to draw some exact drawings. We're going to measure out the angles as we draw them to make it more accurate. All right, so here's my protractor. So we're going to do the herb diagrams like we've already done, but I just want to do them very accurately because we're going to make them a little more complicated. So what you're going to do is you're going to make your perfect half circle with your protractor. Make sure you mark the center and the horizon. So you get a circle like that. This is as good as I can do. I can extend that. Okay. Remember, we always put north on the left, south on the right. That's just for convenience. Didn't have to be that way, but that's just the way we do it, okay? Make my life easier when I grade as well. Okay, so then from Commerce, Texas, What's our latitude? Which means what? Where's the North Celestial Pole?
33 degrees.
Okay, and what's this magic line called? This is the,
Celestial sphere.
it's part of the celestial sphere, but it's a very specific line. The meridian. I heard it somewhere here. The meridian. That is the north-south line. That line is special. Why? Everything rises in the east, and it gets higher and higher and higher, and it reaches its maximum when it is on the meridian, then it starts to get lower, right? So the meridian is exactly straight north and south. We're talking about that with the sun. If it's on the meridian, you know it's exactly south, which is also the point where the sun has the shortest shadows, right? Okay, so I'm going to now put my north celestial pole because I'm going to go up 33 degrees, which on my protractor is right there. Draw that line. That's the north celestial pole. So we're doing the same thing before. We're just trying to do it more precise so far. How many degrees from the north celestial pole to the celestial equator? 90. So you just move your protractor so that the 0 line is on the north celestial pole line. You just go to, you hit 90. Okay, so you make sure that's an exact 90 degrees. Draw that line and label that as celestial equator. Okay, so now we know, or we made this. This is 33 degrees. This is 90 degrees. This is 57 degrees, right? Because it has to add up to 180 degrees. Okay. Now what I want to know is today, it's February 2nd, which is Groundhog Day. I don't see any excitement over Groundhog Day. It's just Groundhog Day, yeah. And by the way, Puxatawny Phil saw his shadow this morning, so we have 6 more weeks of winter. He's such an impressive predictor. Where did I put my book? Here it is. I want to know, or what I'm trying to get at here, is I want to find what the altitude of the sun in Commerce, Texas on February 2nd. I should say what is the maximum altitude. Because we only care about its maximum height. Okay, it actually starts at 0 when it rises, goes up, and what we want is the maximum altitude. Or the altitude when it's at solar noon. All right, so I know this is correct. What does altitude mean? How high from what? Horizon up to the object, right? So the horizon, remember, is the bottom line. So we got to figure out where to put the sun on here. Okay, how are we going to figure that out? Well, we need to know what the declination of the sun is. Remember what declination means?
How far north or south the object is from the celestial equator.
Correct. So grab your Skywatcher's book. We have a fancy dancy chart in here. It's going to help us out. On page 117. Now they don't do it for every day, they do it for every 5 days. So you got to kind of approximate. But you'll see there's a chart like this. Okay. Page 117, table 11. And that gives you the declination of the sun on different days of the year, every 5 days of the year. You can actually get tables and charts that do it for every single date. And ship captains would have that so they could look it up any day of the year. But here, we're not that picky. We just want to be approximately where it's at, okay? Or as good as we can do. So the date today is what? February 2nd. Okay, so right now they have January 30th and they have February 4th, right? We're going to be about halfway in between those two. Okay. So what I do is I look on January 30th, it says it's minus 17 degrees, 49 minutes. On February 4th, it's minus 16 degrees, 24 minutes. You get that? I'll write it down. Because we got to figure out what to put it at. So on January 30th, it's at minus 1749. And on February 4th, it's at minus 1624. This is degrees and minutes. So on February 2nd, what do you think its declination is?
Sorry.
Yeah. So February 2nd is between these two, right?
Oh.
So we want to guess what we think the declination of the sun is in here. Where actually it's called interpolating, which is a fancy way of saying you know two endpoints, and so you figure out what it is in the middle. Okay. Notice one thing too. What's it mean when it goes from minus 17 to minus 16? Going. Give me a cardinal direction.
Oh.
The sun is moving north, right? The more, if it kept going more negative, it's going south. If it's going more positive or in that direction, less negative, it's going north, which makes sense, right? At this time of year, the sun's getting higher and higher in the sky, right? And when does it switch from negative to positive numbers? Not the solstice, the equinox. What day is the equinox?
Around 22nd.
Yeah, March 22nd. So it's going to be negative declination all the way up until March 22nd. Then it's going to go positive from March 22nd until September 22nd, then it's going to go negative again. So it spends half the year negative, half of it positive. Okay? All right, so I would look at this and say, this is minus 17, this is minus 16, right? This is at 49 minutes, this is at 24. Are you with me? So this is about 1 degree and about 20 minutes difference, right? So far, so good? Okay. So 1 degree and 20 minutes is how many minutes? How many minutes in a degree?
60.
60, right? So 60, 1 and 20. That's what I said, right? 1 and 20. It's 60 plus 20, which is 80 minutes, right? What's half of 80 minutes?
40.
40. So I would say that February 2nd, and here, is about 40 minutes from either one. You can do either one, which would make this at minus 17 degrees, 40 minutes. Or if you said 7 degrees, 50 minutes, somewhere in there. I'm not going to be real picky. It's just got to be somewhere between those two, right? Okay. I'm sorry, not 40. 17 degrees, 9 minutes.
I'll say what? Yeah.
Sorry.
Can we do that again, but slower?
Yeah, I lost you totally.
Yes.
Okay. What I did is I just looked at the difference between these, right? These are degrees. So I just subtracted them. I said 17 minus 16 is 1 degree, right? 49 minus 24 is roughly 25. I rounded it to 20, okay? And then I said this is equal to 60 minutes, right? So I just said, oh, 60 plus, and I just rounded it to 20. I said, oh, that's equal to 80, and half of that is equal to 40 minutes. Right, so I got the difference between the two. I cut it in half, And then I said, oh, okay, I can either subtract 40 minutes from this, or I could add 40 minutes to this or subtract 40 minutes from this. Now it's going to be off a little bit because I did approximating, right? That's why anywhere in here between 17, 17:10, anywhere around there is pretty close, okay? I'm not going to make you do it, precisely calculate it out. Just, it's got to be in the middle somewhere.
Add to the 16, right?
Right. Because it's negative. That's why I said it wrong the first time too, yeah. And you do the negative number, so you'd have to add it to the one or subtract it from the other. So it ends up in the middle. Okay. So really, if I added this to here, you'd get 1704, not 1709, but it's close enough, right?
So how'd you go from 40 to that? Did you transfer it back to degrees or what?
No, I just took this 40 minutes. And up here, I just said, oh, 49 minus 40 minutes leaves 09.
So you just
Okay.
minus that.
Or I could add it to this one, but then I would get 40 plus 24 is 64. But 64, you take out the 60 and you end up with 1704. Okay, so that's why if you're in that range, you're okay. Any questions about that? Am I so confusing you? Okay. So we just figured out that the declination of the sun on February 2nd is that. I keep changing it every time, don't I? I don't know why it keeps changing.
Sun's just bouncing around.
Yeah, weird thing going on. All right, so that's the declination of the sun, and don't lose the negative because that's critical. Must be a Monday, except it's a Tuesday, but close enough. All right, but that's in degrees and minutes. We want it in.
DMS.
No, it is in DNS, degrees, minutes, seconds. We want it in just degrees. So keep your mask on. How do we do that? We already learned to convert that, right? What do you do with the 9 minutes to get it to be a decimal? Divided by 60. So we're going to take this divided by 60. And what do you get? Oh man, I forgot my calculator. Somebody get a calculator. What's 9 divided by 60? It's going to be 0.1 something.
0.15.
0.15, okay. So this is going to be minus 17.15 degrees. So far, so good? All right, now that we got the declination of the sun is this, we can put it on our diagram. Where are we going to put it?
Of the celestial equator, 17 degrees.
Which way? This way or this way? South. Why? Because it's negative. Negative means it's below or south of the celestial equator, right? So, put your protractor on the celestial equator. So that 0 is pointing towards the celestial equator. And then I'm going to go 17 degrees south of that. I'm going to go 17 degrees this way. And I'm going to go 0.15, so just barely past 17. I'm going to put the sun right there. Then I'm going to draw that line to the sun. And I'm going to label that angle as 17.15 degrees.
It's 17 degrees from the celestial equator.
From the celestial equator.
Oh.
Remember, declination is always from the celestial equator. That's why we have to know where the celestial equator is, because once we know that, then we can figure out where all the stars and planets are, because they're all given a declination. All right, but the question didn't ask what its declination was. What did the question ask? What is the altitude of the sun? So what is altitude? Altitude is measured from the horizon. So what I really want is that angle right there. What'd you get?
39.85.
Okay. So you took 57 minus 17.15 and got 39.85. That is what our answer was. It's 39.85 degrees. That's what I'll be looking for. Everybody see how we did that? Why we subtracted it from 57?
Because it's a negative number.
Yes. And because 57 is the altitude of the celestial equator, right? So you always start with 57 and either add or subtract to that depending on where the sun is. So when you're figuring out where anything is that you have a declination for, you always have to figure out the celestial equator first and then you go from there. Technically, you're always adding the declination, but sometimes you're adding a negative number, which is just like subtracting. Yes.
So my line turned out extremely small or extremely large. Would it, is this because like line 17 is right here? Or, but it goes down to
Oh, you got to draw your, did you draw on the outside of your protractor?
no,
That's, will give you a problem.
okay, so draw on the outside.
Draw on the outside,
Okay.
yeah, you gotta use more paper.
Okay.
Okay.
No, I thought, because, yeah, I thought I saw you draw on the inside of yours.
I drew mine on the outside too. The problem is on your inside, on your protractor like yours is,
Mhm.
the 0 is not up where the inside was, and so what you're doing is you're missing degrees on the ends, and it's gonna be wrong.
Oh,
Okay.
Now I know my problem at least.
Let's do this again. But let's do this. What are the maximum and minimum altitudes of the sun from 42 degrees north latitude? The latitude of Boston, Massachusetts. I used to live there.
Really nice.
All right, what are we gonna do? Get your protractor, draw your picture, make sure you're doing the full 180 degrees.
It's okay if it goes off the sides, right? I guess we're gonna have like these when we're doing homework.
When you do the homework, like I'll give you a sheet, you're gonna do it on separate sheets of paper.
Okay. I just mean outside the red.
Oh, yeah. The key is just making sure you get an exact half circle. And you mark the center. You should have a dot or something that marks the center, right? Okay, so same way we did before. And make sure you label it. If it's just a bunch of lines without labels, then it's going to be wrong. Even if you do it right, if there's no labels, I don't know what you're doing, okay? So make sure you put north and south. Don't assume I'm always going to do that. If they're not there, I'm going to take out points. All right, how do I start?
You put 42 degrees on there, and you find the celestial equator
Okay, but first, before I do that, I have to do,
with no celestial pole
right. And where's that going to be?
at 42 degrees latitude.
Yeah, but on here, what is it going to be? It's going to be 42 degrees.
North.
Altitude, thank you. I heard somebody say it. I mean, I'm going to go up 42 degrees from the north point, right? Okay, so put your protractor there and go up 42 degrees. And then draw your line. Make sure you label this as the North celestial pole.
I think I'm messing up when I'm drawing with it. I don't know. Do I draw on the outside?
No, the outside.
Because I was having issues when I did it on the other one too, and I did that one on the outside though. So
Well, let me see. I have to look at your protractor. Because some protractors are weird.
because like the 0 line for it is in like the middle.
Oh, yeah.
I got that from the book
Okay, so
shop.
you're gonna have to draw the circle from 0 to 1, but then don't draw this bottom one. You connect those with it and draw it across, okay? So they make protractors weird because we need to connect the 0 and the 180. If it's in the middle of yours, you can't draw that line or that line because neither one of those is gonna be right.
Yeah, because I messed up my last one because I just saw that it was in the middle of
Yeah.
that. So
Does that make sense?
Trying to figure
So you
out.
gotta look at your protractor. They do different ones differently. Mine works because you see the 0 and the 180 are both on this line, so I can just draw this line. But if your 0 and 180 are not on that line, if they're in the middle here, then you're gonna have to just draw that and then move this until you can get the two connected. Okay? Yeah, I don't, all the different protractors are slightly different, so no control. There's no, or I should say, standard. All right, what do I do now?
Find the celestial, well, you gotta find it, that degrees, you gotta label that degrees as 42 degrees.
Okay, I can do that.
And then now you wanna find the celestial, you know that the celestial equator is 90 degrees from the north celestial pole, so you label the celestial equator.
All right, do you guys agree with it? All right, so we're gonna go, yep, 90 degrees from the north celestial pole. So make sure you line up your line with the north celestial pole. Put your zero is always here at Herb's feet.
You need a third one, everyone, by the way.
Do I need what?
You need us to draw a herb.
No.
Okay.
It's pretty and nicer, but you don't have to. All right. And we're gonna draw that line. We're gonna label this as a 90-degree angle. So I make it a square. Okay. Then I need to know this, the altitude of the celestial equator. How am I getting that?
42.
Okay, and how'd you get that?
Because you add the altitude of the north celestial pole and then the 90 from the celestial equator to get like that size, and then you subtract 180 because it's a half circle.
Yeah, it's a half circle. That's exactly what you said. You take 180 degrees, that's half a circle. And then you subtract the ones you know. If I know those two added together, then it's just going to leave that much. So you take 180 minus 90 plus 42, which is 132, right?
48 degrees.
90 minus that leaves 48 degrees. Now notice, do we have any math majors in here?
I wish.
That this is always going to be 100 minus 90 and you distribute the negative, right? 100 minus 90 is always going to be 90. So it's really always going to be 90 minus your latitude. But I don't like writing it that way because then that's not intuitive here. This way you think of it, oh, it's 180 degrees minus this part, right? When you just say it's 90 minus that is mathematically true, but it doesn't help you when you draw it. Does that make sense? There's a difference between drawing it and just saying, oh, I'm just going to memorize this formula. All right, so yes, 48 degrees is the altitude of the celestial equator. Now what?
Oh, shit.
No specific dates for this question?
There are, yeah. If I don't say them, though, we should know what they are, right?
Okay. then it's from-
When's the maximum altitude? When is the sun at its highest declination?
Well, summer
Summer
solstice.
solstice.
Summer solstice, and the declination is
Winter solstice. Oh,
23 degrees, 23.5 degrees, right? So if I say maximum, minimum, you can just use 23.5. You don't have to look up the chart. Okay? So we're going to say the maximum, the declination of the sun, is equal to 23.5 degrees. At the minimum, the declination of the sun is going to be equal to
negative 23.5.
negative 23.5. Okay, so let's put the sun on our diagram. So I'm going to put my protractor so that the 0 line is on the celestial equator now. Because everything measured from the celestial equator, I'm going to go up 23.5 degrees right here. This is the sun on the summer solstice. I'm going to draw that. And I'm going to label that as 23.5 degrees. And I'm going to do the same thing on this diagram for the winter solstice, but the sun on the winter solstice is going to be
Negative 23.5.
yeah, 23.5 degrees south of that, right? So I have to flip my protractor over and measure down 23.5 degrees. All right. Yeah.
I got lost when we got to the maximum declination.
Okay. You got celestial equator? Oh, you're looking good. Yeah. Now
As
go.
far as I got, and I don't know where to go from here.
Yeah. So you're gonna put your protractor on the celestial equator. So the line, line is on the celestial equator.
Okay.
And then you're gonna go 23.5 degrees above the celestial equator.
But where did we get the 23.5 degrees?
Ah, that's the declination of the sun on the summer on June 22nd.
Oh, so we were using June 22nd.
Yeah, because maximum occurs when the sun is exactly at winter solstice.
Oh,
All right, yeah. We need to review real quick, don't we?
I think it's also just us being behind too.
Remember we did this? Yeah, we got on, we did Egyptians and all that, so you got forgotten all this stuff, haven't you? It's all right, it'll come back. Remember we had the ecliptic and we had it like this? And we said, oh, the sun is up here on the summer solstice. The winter solstice, the sun was down here. And then it was at the equinoxes on these two positions. This is the north celestial pole, this is the south celestial pole. This is the ecliptic. And we realized that because of the tilt of the Earth, or if you want to be really fancy, the obliquity of Earth's axis, we know that that tilt is 23.5 degrees, which means on the summer solstice, the declination of the sun is 23.5 degrees. On the winter solstice, it's a declination of negative 23.5 degrees. And on the equinoxes, it's 0. This is the vernal. This is the autumnal back here. So far, so good? All right, so we haven't answered our question, though. This is a perfect drawing. But what are we asking for? We're asking for the altitude, which is from the horizon. So we want this angle from here all the way to here for the summer, and this from here to here for the winter. How are we going to get that?
Add 23.5 to 48 for the summer.
Now for the summer, it's going to be 48 plus 23.5, or 71.5 degrees. And the winter, it's going to be 48 minus 23.5, which is going to be 24.5 degrees. Or if I'm going to label them over here, this is 24.5 degrees. This got a lot of lines on here, is 71.5 degrees. What is the difference in altitude between the summer solstice and the winter solstice? How many degrees?
47 degrees.
47. Why?
It would be 71.5 minus 24.5.
Right? But why is it 47? Because it goes from 23.5 this way to,
23 and a half the other way.
yeah, and 2 times 23.5 is
47.
47. So everywhere on the earth it shifts by 47 degrees from winter to summer. The difference is where it is in your sky. Right? So if you're closer to the equator, it's higher and higher. If you're closer to the poles, it's lower and lower. If you're on the North Pole, half the time it's actually below the horizon. You only see it in half the sky. All right. This making sense? Kind of? All right, we're going to do one more for a very special spot. At the Arctic Circle, what is the altitude of the sun on the winter solstice? Anybody know what the latitude of the Arctic Circle is?
6.5.
Why?
Because 9 minus 23.5.
Correct, but why? You're totally right.
Number. Let's see.
Do this one, all right? I want you guys to do it first and then I'll do it, all right? So just do the problem and then we can check and see if you get the same thing that I get, okay? You're right, it's because of the tilt of the earth, right?
Mhm.
So the key is it's that magic angle between straight up and which way the pole points. That 23.5 degrees determines how much sunlight can get across it, which is why winter solstice is a special day from the Arctic Circle.
What's the latitude of it again?
So, yeah, if you didn't get that, did you miss that? The latitude is 66.5 degrees north. So I want you to do the same thing you did before. Draw your half circle, north and south, but the angle between the north and the north celestial pole is going to be 66.5 degrees. So the north celestial pole is going to be very high, higher than we're usually dealing with. Remember, once you get the north celestial pole, you get the celestial equator, 90 degrees away from that. You're shaking your head like there's something wrong.
There's a lot of
Good.
things.
It's a stupid protractor.
I hate it so much.
Get a different one. They're like all of like 89 cents at Walmart.
Oh, yeah, no, I'm gonna
You,
get a
I went to
different
the bookstore and they gave me this. A long time.
I mean, it works fine. You just have to figure out how to make it work, right?
You put her on a line.
You just got to be careful about the 0 and 180.
Makes me take 3 times a day.
I'm about to lose my mind.
No, degrees. It's making my OCD really bad.
I'm sorry, I can't help you with that. Should have started out like that, right? Okay. Then you should go 90 degrees from there. Are so good? And then you found the altitude of the celestial equator right here, right?
24 degrees. Oh, shit.
Don't round it. How about 23 and a half?
Yeah.
Okay. You can tell this is special, isn't it?
It is.
So where's the sun?
Right there on the celestial equator.
Not on the celestial equator, it's at the winter solstice. Its declination on the winter solstice is negative 23 and a half, so it's 23 and a half degrees
So,
south, which puts you right on the
horizon.
horizon, yes. So where's the sun? The sun is right here. Which means it never rises. If you live on the Arctic Circle, for that one day a year, you have 24 hours of darkness.
Whoa.
Okay? And it's actually quite a few days around it because the sun moves very slowly around the solstices. So all you do in December and into early January, you see a little glow in the south for maybe 30 minutes to an hour a day, and that's it if you live on the Arctic Circle. Yes.
So when it's dark, is it still at AM?
It still happens around midnight, yeah, because that's how we define when would be that. That's when the day changes. When you'd see the sun would be at noon, because this is always around solar noon, right?
Mm-hmm.
Please don't race.
Okay. But since we got this, everybody got this
No.
to do well? What about the opposite? Where's the sun on the summer solstice?
On the celestial equator?
No, that's the equinoxes.
47 degrees.
Yeah, it's up here, 23 and a half above it, right?
Oh, yeah, yeah.
So I'm going to put it on here too. Put it on here. This is the sun on the summer solstice. Right there. So far, so good. What? This is going back 2 weeks again, so you gotta rewind your brain. What are the declinations of stars that are circumpolar from the Arctic Circle? Remember how we figured out that?
What? Circumpolar stars?
Yeah, what are the declination of circumpolar stars from any latitude? We just took.
It's the 90, subtract it from the latitude from the celestial equator?
No, you got some things right in there, but
On the most celestial.
to get circumpolar, remember, it's any stars that are within the same distance as the latitude, right?
Yes.
Of the pole, but you don't measure it from the pole, so you have to take 90 minus that.
Yes.
So for circumpolar stars, you take 90 minus your latitude,
Which is 66.
and it's all stars that are greater than or equal to that, right?
Yes.
Well, in this case, it's 90 minus 66.5, which is 23.5 degrees.
Yeah.
Oh, what's the declination of the sun on the summer solstice?
23.5 degrees.
Oh, son of a gun, for one day of the year, it's circumpolar. Which means what?
It never sets that day.
It never sets. You have 24 hours. Now, what it does is it dips. So it'll go in the north, it'll get real low to the horizon, and it'll go up to 47 degrees, but it never actually goes below it. And around the summer solstice, you get lots of hours of daylight. In fact, it pretty much never gets dark. I had a friend that went to the University of Alaska in Fairbanks, which is not at the Arctic Circle, but it's close. It's at 64.5 degrees, so it's really close. I went to Fairbanks, visited, beautiful place. I was trying to drive to the Arctic Circle just to do that, but then the roads up there, once you get outside, they just kind of disappeared. I was in a rental car, and I'm like, oh, there's no way I'm gonna get stuck and get eaten by a bear or something. So I bailed on that. I only got to like 65.5 or something like that. I was watching my GPS. I wanted to make it, but it's like, no, it would have taken another 2 hours, and I probably wouldn't have made it back. But probably if I would have gone on a different road or something, but I was like, oh, I'll just go north out of Fairbanks. How bad can that be? Yeah, that was a bad idea. But he was interesting because he used to tell me they used to go golfing in the summer, and they used to go golfing at 2 in the morning. But it was perfectly light out because it never got dark. And they quit charging, the golf courses quit charging at 2 in the morning. So you'd be a broke college student, you go golfing from 2 to 5 in the morning because they don't charge. So there's nobody out there but college students golfing from 2 to 5 in the morning. Then they start charging again, so you have to get off the course. But yeah. And also, if you don't grow up there, it's so weird that they have to worry about things. You get lots of murders and suicides because in the winter when it's dark all the time, people start to get cabin fever and start to freak out. Now, the people that grow up there, they think that's just normal. But it's when people like us that are used to days and things changing, it's hard to adjust. All right. Does this make sense?
Yes, sir.
Are you sure? Okay. Because I'm all of a sudden, whenever I say that, I'm going to make it harder, right? Like, no, yes, I am. Okay. By the way, this is not the only special point of the Earth. We also have the tropics, the Tropic of Cancer and the Tropic of Capricorn. Have you heard of those? Tropics? Okay. Let me ask you this way. On what days of the year is the sun directly overhead for 15-degree north latitude?
So stressed to keep breaking my pencil.
Sorry to stress you out. It's my job.
I'm just out of ADD medicine, it's okay.
Move you out of the comfort zone, right? Hey, guess what we're gonna do? Draw a picture. Yes, you can tell all your friends. Dr. Montgomery's obsessed with drawing these pictures. And you'll get good at it. So good, you'll start drawing them in your sleep. You'll start waking up screaming, Herb, what are you doing? Maybe not. All right, north, south. Herb's in the center. All right, we know our latitude, so we can put the North Celestial Pole, right?
Yes, sir.
So we're gonna go, how many degrees?
15.
15? These are very extreme differences here, right? See, over here you have the Arctic Circle, how high the North Celestial Pole is. See how low it is over here. Big difference, right? Several thousand miles there, difference. Okay, and then from there we go what?
Celestial equator,
And how many degrees away?
90.
90 degrees, correct. So far, so good. What do we do next? Find the what?
Calculate this.
Yeah, the altitude of the, yeah, find the altitude of the celestial equator. We're gonna find this angle. All right,
75 degrees.
right, 180 minus 90 plus 15, which is 75 degrees. So far, so good. What's the question ask?
Question said, what day of the year is the sun directly overhead for 15 degrees north latitude?
Yeah, but it said what days of the year? Oh, that's plural, right?
So it's 2 days.
So it happens more than one. How do you know it's 2? What if it's not 11?
2.
You're right, it's only 2. But it didn't say that in the problem, did it?
Yes, sir.
Okay. What does directly overhead mean?
And the,
Straight up at your
Zenith.
zenith, right? And the zenith is at an altitude of 90 degrees. So I'm going to put the zenith on here because that's what it asked. So I'm just going to put a mark at 90 degrees from the horizon. This is zenith, and this is the sun. I need to know that angle. Why?
That's the. Altitude of, no,
No? It's measured from where?
declination of sun.
Yeah.
Yes, it's measured from the celestial equator. From the celestial equator, it's always the declination.
15.
So we're trying to find the declination of the sun. Well, we know that if this thing is 90 degrees, right? Because that's what the zenith is. And that's 75. What's that have to be?
15.
15. Yeah, this is 90 minus 75 or 15 degrees. Is it positive or negative? Positive because it's north of the celestial equator, right? So what days of the year is that? What days of the year does the sun have a declination of 15 degrees?
That's not the,
Not equinoxes is 0. It's not the solstices. Oh, it's got to be somewhere in between, right? So what do? We gotta go to the book. And we got to look on here, look on the chart,
Yes.
and figure out when the sun has a declination of 15 degrees, or close to 15 degrees, you know, it skips. And it's going to happen twice. Why? Because it's going to go up to 23 and a half and go back. So it's going to go through 15 to 23 and a half, and it's going to hit 15 as it goes back down again.
so November 6th,
No, try again, that's negative.
well, you want the positive one first?
No, both of them have to be positive, right?
Like May 2nd and
Okay, I like May 2nd.
May, or sorry, not May, August 11th-ish? Maybe it's too close. to-
February 7th?
No, you're still looking at negatives. No negatives. The sun is north of the celestial equator, right?
Wait,
So
oh,
yeah, I like May, about May 1st
Yeah. I wasn't
or
looking
2nd,
at
somewhere there,
August.
May 1st or 2nd,
Or
and
August
August about 12th.
Well, August, like, 14 and 13. Oh, never mind, I'm wrong. I looked at it and then tricked myself.
Okay, if you got your chart, do you see how I'm picking those dates out?
12th. Yes, sir.
If you don't have your chart, you need to get it. Okay, because we're going to use this a lot. And you're going to actually bring this book to the test, because you're going to need this on the test. You're going to need this chart. All right? Okay. So, does that make sense?
Yes, sir.
Okay? This is easier than it looks. What's the latitude here?
15,
What's the declination of the sun?
15 degrees.
Oh, that makes it really easy, doesn't it?
Yes.
So if I ask what day of the year, or days of the year, is the sun directly overhead, it's any time the declination of the sun equals your latitude.
If you ask what day the sun is directly overhead, any day the sun equals your
The
latitude.
declination of the sun equals your latitude. So on what days of the year is the sun directly overhead from Commerce, Texas?
So, for ones.
It never reaches.
Oh, I tried to trick you.
Yeah, I was gonna say,
We're at 33 degrees north, right? Does the sun ever get to 33 degrees north? No, the max it gets is 23 and a half, right? So no, it'll never get directly overhead here. We miss it by 9.5 degrees. 33 minus 23 and a half, right? So even in the summer on June 22nd, it never gets directly overhead. It gets to about 9.5 degrees from being overhead. Where on the Earth is the furthest north point that it gets directly overhead? Latitude of 23 and a half. What's that called?
Summer solstice.
No? The Tropic of
I don't know which one.
Cancer. Tropic of Cancer is at a latitude of 23 and a half degrees north. That is the furthest north point where the sun gets directly overhead. That only occurs on the summer solstice, the June 22nd. 22nd.
What is it?
Say that
What
one.
is it, 2 days?
What's that?
What is it, 2 days?
Why is it 2 days here? In fact, I should write down the answers here, shouldn't I? What did I say they were?
Yeah, and then the minus.
says like May 2nd and.
May 2nd, then what was the other one we said?
What'd you say?
August 12th?
Yeah.
And if on a test you said May 1st or 3rd or August 13th, you get it right, okay? I just looking, it's got to be in that range, okay? Don't worry about it. You know, oh, he said first and I said second. That's okay. That's kind of an interpretation. Okay? So remember, the sun, right? On the equinox, it's right on the celestial equator. Then it's going to get a bit further and further north until it hits the summer solstice. Then it's going to come back again. So in this case, it's going to pass through the zenith on May 2nd. Then it's going to hit this on June 22nd. And then on the way back, it's going to pass it again on August 12th.
So it passes the zenith? That's what you're saying?
Yes. So that's why it happens twice. It happens 2 times a year. Because remember, the sun goes up and then back down again, right? All the way to negative 23 and a half, all the way to positive 23 and a half. So if you're somewhere in between, it's going to pass you on the way up. It's going to pass you on the way down. So it happens more than once. What days of the year is the sun directly overhead on the equinoxes? Not what days. Where are you on the Earth? Sorry. I told you the days. The days were the equinoxes. Where are you on the Earth if the sun's directly overhead on the equinox?
You're Archaeoastronomy?
No?
On the equator?
On the equator. What's the latitude if you're on the equator?
0.
0 degrees, right? And remember, to pass directly overhead, the sun has to have the same declination as your latitude. And on the equinoxes, the sun has a declination of 0 degrees. Wow, this seems really confusing. But the more you do it, you're going to get better. This is going to make more sense, okay?
Can you repeat what you like just said before that, I somehow forgot about it. Equinox is on the equator or 0 degrees. Sun's at 0 degrees.
Yes.
Okay, thank you. Sorry,
On the equinoxes, the declination of the sun is 0 degrees.
thank you.
Okay, that means the sun is directly over the equator, right? Directly above the equator on March 22nd, September, which is why on those days everybody has exactly 12 hours of daylight and 12 hours of night. Because it doesn't matter where you live, well, ignoring the poles. Everywhere else it'll rise directly in the east, set directly in the west. It gets confused up near the poles. But the rest of the earth, yes.
But that's what the May 2nd and August falls are? Or?
No, that's a different problem. Gotta stay with the right problem here, because it changes, right? Changes depending on where you live. The Tropic of Capricorn is 23.5 degrees south of the equator. So what day of the year is the sun directly overhead of the Tropic of Capricorn? Yeah, what's the calendar date? December 22nd. Now don't get confused. If you're from the southern hemisphere, you call December 22nd the summer solstice because it's summer down here on that time of year. So we call December 22nd the winter solstice, but they call December 22nd the summer solstice. So for them, Christmas is really close to the summer solstice. For us, Christmas is really close to the winter solstice. So it just makes sense because it's summer down there when it's winter up here. That's why you can travel around and always be in summer if you want. There was a great surfing show called Endless Summer where these two surfers from the 60s just took off and said, we're going to surf all year round. And so when the weather starts to change, they traveled to Australia and to Africa and just followed the sun. It's a great show. You should watch it sometime. I don't know where you find it, but one of those classics, probably Prime or something. All right. Questions? Yes.
It's gonna be after class to talk about.
I can help you. Okay. I do have homework for you, so don't leave. Now, this homework has a bunch of problems like these, so you can practice them. Okay. Then there's a couple problems at the bottom asking about the reading. So if you haven't done the reading, read that story of Haxty, the last girl that was sacrificed. And it's due on Thursday.
Oh, yes. I was like that. It's big enough. Shadowy. Terrible. Yeah.
We used to come in the summer and you start up there and go all the way down.
Oh
to
my
the
gosh, I
pond.
did that the first time. I was like actually skiing. It was so scary, but like.
Yeah, it was fun.
Yeah.
I crashed a couple times, but you know, as long as you go into the grass, you're all right.
Oh, yeah,
You just gotta roll with it, right?
Yeah.
All right.
Bye.
See ya.
So this was Thursday.
Yes, due Thursday.
I don't know.
Extra ones?
Yeah.
Yeah, they're hard to count.
I am not gonna say it. No, I like practically never.
You too.
If you need anything, I'm pretty much available.
Extra, yes.
What else do we need for the exam except the chart from the book?
You need a compass, a straight edge, and a protector.
Okay, can I just print this?
Yes.
Page
The way I want them to.
Yeah.
Yes. Thank you so much. Okay.
insomnia, so I'm just.
Thank
like,
you.
never to sleep.
You're welcome.
I'll say, oh, hell yeah, that's not something to say, oh, hell yeah.
Yeah, I
came
got
a
you.
little late,
I
so-
saw you come in, so I got you.
Oh, I just need to.
All right, who wants to go first?
Charlene.
Okay.
Okay.
Let me see what you do.
I was just trying to keep up, but I'm running a little slow today. I don't have my ADD minutes anymore. But
That looks great.
with these,
But it doesn't make any sense. But you did, the drawing looks good. Let's see.
were really confusing for me. I didn't
Oh, yeah, you
understand.
did great. I mean, your drawings are perfect.
Well, the thing is, I was completing the drawings as you were talking about the next stuff, so like my brain was
Okay.
not.
So you realize how we do them, right? The key is knowing the steps. All right, so you figure out the latitude, you always put the north celestial pole, that's the first step, right?
So I was trying to color code it.
Yeah, and then the second step, you always put the celestial equator, 90 degrees away, right? The third step is you figure out that the altitude of the celestial equator. Okay, and then you figure out where the sun is, and you have to read each problem to determine it, right? On this one, we asked for on the summer solstice and winter solstice, that's why they're 23.5.
Yeah.
Back here, we asked for it for today, so we cared about what it was on February 2nd, which is why the sun is here, 17.15 below the celestial equator, right? So, and this was the same thing, but I asked for it on the winter solstice, and we realized from the Arctic Circle, the sun is way down here.
Yeah.
And on the summer, it's up here, and it actually makes it circumpolar for one day.
Yeah.
I think you'll be able to do these. What you should
I don't
do,
even know what the answer to this is. I just wrote whatever down that I saw.
the answer is 0,
Okay, so the answer is 0.
right? Because where is it? It's right on the horizon. Remember, an altitude is how far you are from the horizon. If it's on the horizon, its altitude is
Is 0.
0.
Okay.
Don't panic, okay? Feel
It's
like
just
you're
'cause it was
stressing
in
yourself
class.
out, and that's
If I was like on a
you know.
test doing it by myself, it would have been easier, but I was trying to get my notes done and stuff, so it's just.
Remember, do those steps, okay? And then go do those steps and then see if you can figure it out. If you're having trouble, so what I want you to do is go try the homework, okay? If you're having trouble, come see me or email me, okay? I don't want you to sit there and get frustrated and angry and freak out, okay? But it helps you to try it first. And just say, oh, I don't know, that doesn't work. Just follow the steps and see where you get, okay? I think you'll find it's not as bad as you think. See if we did this one.
I didn't even get to finish it.
You did it right. You just didn't label this. That angle's 15, you got it right there.
I don't understand what we're doing over here. I don't understand how we got these.
Okay, this is from the book, the Skywatcher's book.
I was trying to freaking do the drawings, so I didn't look at it.
You got your pencil here.
Yeah.
I'm gonna add some stuff to your notes, right? So this here is 15 degrees, right?
Mm.
That's the declination of the sun. So you go in Skywatchers,
It's 117.
page 117, and you look for the days when the declination is equal to 15 degrees. That's how we got those 2 days.
Okay.
Does that make more sense?
Yeah. Because when we were looking at that, we did the one that was like 15 and then it had the minutes and then we did all the converting. So my brain was on that for the chart and not for those also. going.
You're right. I was probably going faster than.
Yeah,
make it
I'm a really
tougher.
slow writer and drawer, so like I just.
But your pictures are very nice.
Oof,
You did a nice job.
I have the protractor with the thing in the middle, so like I'm.
But you're getting the hang of it now, right?
Kind of. Thank you.
You are. Yes, sir.
So, I was going to ask about those ones.
Okay.
But I think I figured it out now.
Which one?
Yeah, we used to draw it like this.
Mm-hmm.
And I wanted to draw this one. And which one was it? Minimum difference of no altitude of sun from 4 degrees altitude, right?
Right.
So, I think, yeah, sun goes around Earth like this, right? So, yeah, right here.
Yeah.
So I was worried like if sun is on like negative 23.5 degree. I thought I had to draw like on this side.
It would
But
be.
it's out on this side, right?
Now this,
So
on
is
this side, when, the way you have it drawn here,
Uh-huh.
well, this is confusing the way you have this drawn here.
Yeah, that's what but now I
That-
think
That's
I
gonna
understand.
confuse you more.
Yeah, that's right.
So what it really means, where's my globe at here? All right, so if the sun, if you're here, 42 degrees, which is over here in Boston, right? If the sun is at 23.5, it means it's down here, right? So from here, it's looking low. It's 23.5 below this, and would be parallel to that distance, okay? In the winter, you're still here. It's gonna be up here, 23.5 above, so it's gonna seem very high in your sky because you can only see everything on this side. Does that kind of make sense?
Yeah, it does. On this one, on commerce. So I was gonna draw this sun right here on this side. Because it
No,
would be on
'cause
this side, but yeah, but now I get it, but because it's like.
Because we
it's
can't
like-
see through the earth, right?
Yeah,
Right, so
Yeah, I see
we
it.
can only see it up here, and this is the sun at noon on that day.
so yeah, I get it, because Earth is moving around like this, sun goes like this, not like around the.
Right. The
I
sun
think
is
that's
gonna
what it is.
move parallel to the celestial equator. So it's
Yeah,
gonna
so
make
it's
a
just
circle
gonna go
parallel
right-
like this. So
right
it's gonna go like this,
Mhm.
but we
But
only
we
care
only see
about it
here.
when it's at that, on
Yeah,
the
if you're
meridian.
on horizon, so we'll just see like going like this.
No, if
We'll
it's
see-
rising, it's gonna rise back here, it's gonna go like this.
Mhm.
It's gonna make a circle like this.
Yeah, now I get it now. Sun is, I mean, like we would think sun here because Earth's rotating.
Right.
If it was like transparent, we see going around like this, and you.
We'd still see it going around parallel to the celestial equator though. It's still gonna go in a
like,
circle.
Yeah, right here.
Yeah.
Sorry, yeah,
Parallel
that's
to the celestial equator, all right.
right. So yeah, that's what it was.
Right.
And is it possible that I come in like I'm like once a week actually?
Sure.
I was gonna ask you. I mean, like, I got all the notes I see the outlines that you have.
Yeah,
So I think I made a pretty good note on last semester.
okay,
I mean, like universe.
okay.
What was that? I mean, last class.
From, what, did you take me before?
Yeah, I did. That's why I
Okay.
took this one. So
When you were online?
yeah,
I
online.
didn't meet anybody online, they were just names.
Yeah, it was pretty good. I mean, like I learned a lot from like online classes because I had to watch like all the videos. And
So
it's
this should be a lot of this I did in the other
like, yeah,
class.
see this the capital.
Yeah.
So I took
Good.
all the
Remember
notes
all
from-
that, that's good stuff.
Yeah, that's what I was trying to do, and like I looked at the outline and like everything was same, like these ones and the moon phases, right?
Right, yeah, we haven't got to the moon yet in this class, but we will talk about
Yeah,
it.
so like I think I can cover if I come like every Thursday or I mean like every because I have to drive like almost 86 miles from Irving every year just for this class. And if it was like last time, it was like about pyramids and stuff. So
Yeah, sorry.
yeah, coming around right here for like just if I had another class, I would like come a little early and spend time at the college. But it's just one class, so
Yeah, but
yeah. If I have like any outdoor activities or quizzes, I'll be here. I don't have any
Okay.
problems. But if I don't, like if it's just like lectures like this,